All right, yesterday we talked about the law of sines, and today we're going to talk about the law of cosines. So, the law of sines is pretty easy to use and to remember, but it only works if you have an angle that's useful. For example, if I have angle B, then I have to know side B, or if I have angle C, then I have to know side C. They have to be a pair. So, if we're given an angle that does not have a pair or no angle at all, then you would want to use the law of cosines. It's just as reliable, but it's not as easy to remember as the law of sines. But that's why we have this one also, in case we don't have an angle matched up with a side if we don't have a pair. All right, just FYI, because I know you're already going to ask me, these formulas, including the area formulas from the first time, the law of sines, will be given to you on a card whenever you have to take an assessment. So we do not expect you to memorize these, although the law of sines you probably do have memorized because it's easy to remember. You will be given them because we all know that I don't have these memorized. No regular person has these memorized. Okay, so law of cosines uses these three angles or these three formulas depending on which angle you have. All right, so solve the triangles, round answers to the nearest tenth. So we know angle B, so let's go ahead and use this middle formula so that we can find little b. I'm also going to need to find the other angles, so I'll show you how that works too, but let's use this middle formula to start. So I have b squared equals a squared, which is 25 squared, plus c squared is 12 squared because it's straight across, minus 2 times a c cosine of 80, because that's our angle B. All right, and I'm just going to type this whole thing on the right side into my calculator. Okay, so I get 664.81, and then I have to square root that. And it says round to the nearest tenth, so we'll do 25.8 centimeters. Okay, now we have to find the other two angles. So let's say we want to find angle A. I'm going to use this top formula because it has angle A included in it. So this one says a squared, which is 12. So 12 squared equals b squared, so 25.8 squared, plus c squared, which is 12 squared, minus 2 times 25.8 times 12 cosine of A. Okay, now we're trying to solve for this big A. So obviously here I have 144. Or actually not 144, that's wrong. It's 25 squared. Okay, because little a is 25. So 625. Now I'm going to simplify what I can here. So I'd have 809.64. That's this piece. I squared those and added them together. And then I'm going to multiply all of this together. Is 619.2 cosine of A. So then I'm going to subtract this from both sides. So that's negative 184.64 equals negative 619.2 cosine of A. So I'm going to divide both sides by our negative 619.2. And you get 0.298 equals cosine of A. And then you take inverse cosine of 0.298. So angle A is 72.7 degrees. And then I'm just going to take 180 minus 80 and minus 72.7 to get 27.3 degrees here. Okay, now we've solved our triangle. Okay, for this next one, I know all three sides, so I can start with any of these. But what helps you avoid some errors is if you are trying to find all three of your angles, try to solve for the largest angle first. It helps make sure you're on the right track. So I'm going to use this middle formula again because it looks like B is my only obtuse angle, so it's going to be the biggest. And these aren't always necessarily drawn to scale, but I know it's the biggest because it's also across from the largest side. So we'll do B squared, which is 25 squared, equals A squared plus C squared minus 2 times A times C cosine of B. Okay, and then I'm going to solve this like I just did the last one. So I have 625. Here I have 369 for this piece. And then I'm going to multiply these together. Is negative 360. Okay, so 625 minus 369 is 256 equals negative 360 cosine of B. So I'll divide that by negative 360. It's negative 7.1 repeating equals cosine of B. Oh, not 7.1, 0.71 with the 1 repeating. All right, and then I take the inverse cosine of that, and I get 135.3. Okay, so that's this angle. Okay, then I just need to solve for one more, either A or C, and I can subtract from 180 to find the last one. So let's say we want to find A. I'm going to have A squared equals B squared plus C squared minus 2 times B times C cosine of A. Okay, and we're going to do the same thing here. So I have 225, 769, minus 600 cosine A. So then I have negative 544 equals negative 600 cosine A, which gives us 0.91 equals cosine of A. So if I take the inverse cosine of that, I get 25.0 when it, yeah, 25.0. It's going to round up to that. Right? So if this one's 25, and I can take 135.3 and 25 away from 180, and I get 19.7. Okay, and your smallest angle should be across from your smallest side. So if you do that, that's a quick check to make sure you're on the right page. All right, we do have a couple more. If you turn your page. An organism's steep angle is a measure of walking efficiency. The closer the step angle is to 180 degrees, the more efficiently the organism walked. The diagram shows a set of footprints for a dinosaur. Find the step angle B. So they want us to find this angle. So we're going to use the formula, this middle one that has cosine B in it. So you're going to have B squared, which is 316 squared equals A squared plus C squared minus 2 times A times C cosine of B. Okay? So that's how that would be. And we're not solving the whole triangle because it only asks for the step angle B. So then from here, I'm going to simplify what I can. Okay, keep going by subtracting 62,834. Okay, then I'm going to divide by 61,070. Negative 0.61 equals cosine of b, and then I have to take the inverse of that. So I got 127.3 degrees is angle B. All right, last one, I believe. A surveyor makes the measurement shown to determine the length F of a walking bridge to be built across a pond in a city park. Find the length of the bridge DE to the nearest tenth. So we're trying to find F here. Again, we don't have to solve the whole triangle, it just asks us to find this side. So you could even rename these to ABC if you want. So like if we do ABC, then I'm trying to find little a. This is little b, little c. But the problem here is that I don't know enough side lengths. I know multiple angles, but I need at least 2 side lengths to do law of cosines. So what that means is this is actually a law of sines problem. So I'm going to go ahead and find this third angle by taking 180 minus 79 and 65. So this angle would be 36. And now I'm going to do law of sines. So I'm going to say that the sine of 36 over its side of 45 equals the sine of 79 over little a. So if I cross multiply, I have a times the sine of 36 equals 45 times the sine of 79. And then I'm going to simplify what I can from here by typing it in. So I would have 0.59a equals 44.2. And then if I divide that, I have side A is 74.9, and then that would be feet. Okay, and that the side they gave us goes with that one. This was my biggest angle, so it makes sense that this side is longer. So they're not always drawn to scale, but again, your biggest angle goes with your longest side, your smallest angle goes with your shortest side. All right, your assignment for today are pages 9 and 10.